This is my intersection shield plugged into my Dolgan development board. I'll get straight into a demonstration with the lights off so you can clearly see it working and see the lights better. Here it is. As you can see, it immediately starts with a countdown from 7 to 0. Once it reaches that, the green light will turn orange for a second, then to red. From there, they both hold at red for a second, then it'll switch to green. The countdown will start after 2 seconds and once again reach 0. And this will repeat both ways and continuously until I turn it off or tell it to do otherwise. Now that the lights are back on, I would like to talk a bit more about the intersection shield and its relationship with the Dolgan development board. The pinout actually in comparison is pretty simple. The first 6 pins of the Dolgan development board, port A0 to port A5, are dedicated to the 6 LEDs here. The next 2 pins, port A6 and port A7, are connected to the transistor pins. Then, port B0 to port B3 are connected to the 3 binary inputs of this chip. Unlike the ADC shield of last time, this is actually not a shift register, but instead the 4511 chip. This chip is far different, and instead, what it does is it takes 4 binary inputs and converts it to decimal that is displayed on a 7-segment display. I've drawn a diagram to more clearly explain this perhaps, and here it is. In this diagram, for simplicity's sake, I've decided to ignore the basic power, ground, and etc. pins, and instead focus on the direct inputs into the 4511 and its outputs. If we look at this on a coding level, to set this whole thing in action, there is basically only one line of code needed. Port B equals blank. If I was to, let's say, for example, put the number 7 in here, which is one of the lines that actually runs through this code in the for loop, which is explained in my DER, we'll actually see something unique here. So what will happen to the rest of this code is that it will display a 7 in binary on that port. What that looks like, since the DDP only has 4 B ports, it'll look like this: 0, 1, 1, 1, setting high the first 3 pins in that port. Since the first 3 pins are connected to the inputs of the 4511, the 4th is actually just connected directly to ground, so we do not have access to it. But the first 3, since they are connected, what we would see here is a high on the first 3. What this does is that it'll then go into the 4511, it'll process this, and look at its storage and what it is programmed to do, and realize that with this input, it has to turn on 3 segments of the 7 segment, which is A, B, and C. So I'll put a high on A, B, C, and then a low on the remaining segment. And through this, it would turn on the 3 corresponding segments on the 7 segment and display a 7. This is a pretty brief explanation about how the 4511 works and the code I use to run it. Otherwise, yeah, this is all.